Hello and welcome to the videos for Algebra 2. This is Unit 2 notes, and this is a section called Factoring Quadratics. This is kind of a review section. This is something that you've learned in Algebra 1, hopefully, but I want to just make sure that we know how to do it before we start the next section in Algebra 2. So the first thing we want to talk about is factoring polynomials and factoring the greatest common factor, GCF. Okay, we want to determine the greatest common factor, or the greatest common monomial factor of two or more terms. We want to write a polynomial as the product of a monomial and a polynomial having the same number of terms. And then we want to determine an appropriate way to factor a polynomial for a given context. So when we talk about factoring, I like to think of it as the opposite of distributing, okay? And we'll talk more about that. But basically, factoring is, I also think of it as rewriting as the product of two numbers. Okay, product of, and not just two, of multiple numbers. So multiple numbers. Okay. And so, we have this little thing here that kind of tells us about factoring, and it says, find the greatest common factor of the terms in a polynomial, write each term as a product where one factor is the greatest common factor, and then use the distributive property, okay? So before we do anything, we do want to talk about factor trees and finding the greatest common factor of two numbers, okay? Remember that factoring is the opposite of distributing. So we want to rewrite as a product of multiple numbers. So if I wanted to find, say, the factor tree or the greatest common factor for the numbers 45 and 36, then what we would do is we want to rewrite these numbers as the product of two numbers. And so the guaranteed way to figure this out is, taking this number 45 and rewriting it as the product of 9 and 5. And if you rewrite it as the product of 9 and 5, 5 is a prime number, okay? We can't go any further than that. But 9, we can rewrite that as the product of 3 and 3, okay? So if we take 3 times 3 times 5, it'll give us 45, all right? Same thing with 36. We look at 36 and you say, okay, well, we could rewrite that as 2 times 18. We can rewrite 18 as the product of 2 times 9, and then rewrite 9 as the product of 3 and 3. Now, what you need to notice here is when you get down to these prime numbers, you need to figure out how many of these prime numbers do you have in common. And so since you have two common 3's in each of them, then we know that 3 times 3 is equal to 9, and that's your greatest common factor. Okay. Now, a lot of times you can just do this in your head. This is a guaranteed way to figure this out. So just something to think about and always refer back to if you can't figure out what the greatest common factor is. So let's take a look at this. It says finding the greatest common factor of two monomials. So, we have the greatest common factor of two monomials consists of the greatest common factor of the coefficients and the greatest common factor of each variable that is common in both monomials. So we have this monomial here, 36x to the fourth and 45x cubed, okay? And we want to find the greatest common factor. So the first thing we want to do is find the greatest common factor of 36 and 45, which we've already done, and that's going to give us 9. Okay, but then we have to figure out, okay, well, what about the variables? What about x to the fourth and x cubed? So let's do something real quick. If I take x to the fourth, that means that I'm taking x times x times x times x. I'm multiplying x by itself 4 times. Now, if I take x to the third, that means I'm taking x times x times x. Now, that means that we have 1, 2, 3 common factors of x out of this, okay? So our greatest common factor out of those is just going to be x cubed. Now, there's kind of a trick to this, and there's kind of a pattern that you can notice in that whenever you have, variables raised to a power, you have to look at the exponents, and that kind of tells you what the greatest common factor is. But we always choose, okay, our greatest common factor is always the variable with the smallest exponent, okay? And that's it, okay? So if we wanted to find the greatest common factor of 36x to the fourth and 45x cubed, then we simply just combine these two numbers and we get the greatest common factor of 9x cubed. And that's it. And that's something that we could factor out. Now we're just finding the greatest common factor. We're not factoring anything out at this point, okay? So let's take a look at the next one. Now the next one, we've got two monomials with multiple variables. So now, okay, we have to find the greatest common factor of, of 72a squared b to the fifth and 27a cubed b cubed. So we want to look at each of these separately. Okay, we want to first say, okay, well, what's the greatest common factor of 72 and 27? And, right off the bat, that I can't really think of that. So I may need to do a factor tree or think of the multiples of 72 and 27. Now, 27, all right, and I'm just going to write those over here. 27, one way to do this is to look at the multiples and say, okay, I've got the numbers 1, or the factors of 27. And 27, I know that 3 goes into 27 9 times, and that's it. Okay, me thinks it's going to be 9. Okay, I've just got a hunch. Okay, but if I take 72, all right, and I factor that, then I know, I have 1 and 72. I've got 2 and 36. And then I'm sure that goes into 3 and 24, I believe. Okay, there's quite a few of these, but and the thing of it is, now that I've seen these, okay, I've got a 27. None of those other numbers are going to be bigger. I don't have 27 anywhere else in here. 27 doesn't go into 72, and then the other one that I have is 8 and 9. 8 times 9 gives me 72. So what I notice is that 9 is the largest common number out of these numbers, out of these factors. So my greatest common factor is 9. So that's another way to do it. You could just write out the factors of it. And so I know that we've got a factor of 9. Now let's take a look at the greatest common factor of a squared and a cubed. And remember that we just use the smallest exponent. So my greatest common factor is going to be a squared. Okay. Down here, the greatest common factor between b to the fifth and b cubed, we're going to take the one with our smaller exponent. So that's just going to be b cubed. So putting it all together, the greatest common factor of each of those terms is going to be 9a squared and b cubed. And that's it. And we're done. Okay. All right, let's take a look at the following one. It says finding the GCF of 3 monomial terms. So we want to find the GCF of 27, 18, 33. We've got g to the fourth, g squared, and g to the sixth. Now notice that this doesn't have an h term in it. So that means that because this term doesn't have any h's, we can't find a common factor with these as well. So there actually isn't going to be any other g term or any other h term. So let's take a look at the numbers 27, 18, and 33. So 27, 18, and 33. 27, the factors of 27 are 1, 27, and then 3 and 9, okay? With 18, we've got 1 and 18. Okay, we've got 2 and 9. So it looks like between these two, I've got a common factor of 9. And then 3 and 6. Okay? And then with 33, you've got 1 and 33. But then the only other thing you have is 3 and 11. So the largest common number out of any of these lists is going to be 3. Okay? And that's going to be our greatest common factor. So out of those numbers, we've got 3. Okay? Now, the smallest g term with an exponent is going to be g squared. So 3 and then g squared, you can factor that out. But because this doesn't have an h term, we don't include an h in our greatest common factor. So this is it. This is our answer. Okay? So, this should be a review for you. But we just want to make sure that you can look at numbers and find out what the common factors of each of those are. Okay, on the next page, we were talking about the distributive property. And remember, the distributive property means that if you've got, some number A times the sum of two other numbers, then that you can take A times B and then A times C. So you can take A times the values on the inside of those parentheses. Okay, so it's something that you've been doing for a while, but when we distribute, okay, we're used to that. All right, we go one way. And, typically we draw our little arrows here. We take 3x times x and 3x times negative 2. And so we get this. We get 3x times x. We multiply the x's together. X times x gives us x squared. And then minus 3x times 2. So we take the 2 and the 3, multiply those together to get 6, and we just keep the x. Okay, now factoring means that we go the opposite way. So going this way, okay, we're going to call going this way to distribute. But going the other way means to factor. Okay, it's the opposite of the distributive property. So we start off, okay, with what we ended up as in the other equation. So notice how after distributing, this is where we got to. When you factor, that's what you start with, okay? And so then what you do is you start off with 3x squared minus 6x, and you go, okay, what is common, what's my greatest common factor between 3x squared and 6x? And so, 3 and 6, okay, both have a common factor of 3, okay, right there and right there. And then, between x squared and x, the common factor is just x. So that's the hard part, is sitting there and going and rewriting that and saying, okay, how could I rewrite 3x squared minus 6x? How could I rewrite 3x squared as the product of two things? How could I rewrite 6x as the product of two numbers? Okay, and then what we do is we actually have a common, 3x squared here that we factor out, and we get this last final statement down here, and we get 3x times x minus 2. Now, the way to check, and remember what we were doing here is we were factoring, okay? We can check by doing the distributive property and going back the same way, okay? So you're just going in a circle, but if I wanted to check, then I would take 3x times x minus 2, and I would distribute that 3x. And I would say, okay, I've got 3x times x minus 3x times 2. And if I do 3x times x, that's going to give me 3x squared, and then minus 6x, which is the same thing that we started with, okay? So, all you're doing is the opposite of the distributive property, all right? So let's practice, okay? Let's take a look at one of these, and it says factor the polynomial 12c to the 9th plus 28c to the 7th. Now, with 12 and 28, I've got a common factor of 4, I believe. So with 12, the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, and then 28, we've got 1, 2, 4, 7, 14, and 28. And so the greatest common number between those is 4, okay? And then my smallest, between c to the 9th and c to the 7th, I've got, the smallest exponent is 7, so c to the 7th. So my greatest common factor, okay, is going to be 4c to the 7th. Okay, so let's do this. Let's do something here real quick. Okay, let's rewrite this as the product of two numbers that includes our greatest common factor. So I'm going to rewrite this as 4c to the 7th. Now 4 times what gives me 12? Because we got to think about what's left. And that number is going to be 3. Okay? And that's going to be 3. And then c to the 7th times c to the what gives me c to the 9th. And that's just going to be c squared. Okay? And then, okay, I'm going to do plus. And if I factor out, if I rewrite 28c to the 7th and factor out the greatest common factor, then, if we factor out a 4c to the 7th, then we are simply just left with times 7. And let me do this. Let me put times in here, times 7. Okay? And the reason why is because, if I take 4c to the 7th times 7, I'm getting 4 times 7, which is 28. So, every time that you go from this step to the next step, you should be able to go back and multiply and go back to where you started, okay? That's the big point about factoring, and that's, what we're trying to do, is just rewrite it and go the opposite way of the distributive property. So now what I can do, because I have a common 4c to the 7th, okay, do the opposite of the distributive property. I'm going to factor that out. And so when I factor that out, I get 4c to the 7th, and I'm just left with 3c squared plus 7. And that's it, okay? And so you can recheck yourself, and this is the factored form. This is our answer, okay? But if you wanted to go back and check, okay, to make sure that you're right, all you need to do is just distribute that 4c to the 7th. So if I had 4c to the 7th times 3c squared plus 7, okay, distribute that value. So we get 4c to the 7th times 3c squared plus 4c to the 7th times 7. And so multiply your numbers together. And so we've got 4 and 3 gives us 12, okay? And then c to the 7th times c squared gives us c to the 9th, okay, plus 4 times 7, which gives us 28, and then times c to the 7th, and we started where we started, okay? That's what we had originally. So that's how you know, okay? This is our answer. You can check by, redistributing and figuring that out. Okay, so on these, let's just take a look at, some of these where it says, okay, determine whether the polynomial contains terms with no common factors, then factor it if you can, okay? So on this, between, and these are kind of interesting. Some of these are kind of interesting. On this first one, you've got 12 times x to the 9th plus 5. Okay, if I look at 12 and 5, 5 is a prime number, okay? Meaning it's only divisible by 5 and 1. So, does 5 go into 12? And the answer is no. Okay, I mean, you could factor out a common 1 here, and you could leave it as 12x to the 9th plus 5, but that's just kind of stupid and redundant. So redundant that we call it that's from the Department of Redundancy Department. Okay, so, simply, if we can't factor anything out of it, we simply just leave it where it is. We don't really do anything to it. Okay. Now, over here, and a lot of times, guys, even though I did all this work up here and wrote out the greatest common factor and all this kind of stuff, honestly, it's going to get to a point where we need to just be able to go from this step to this step. If you got to write everything out, then do what you got to do. Okay. But over here, when I look at, say, something like 62 q to the 10th plus 31 times q to the 9th, then I look at the numbers 62 and 31. And those numbers, to me, I'm like, okay, well, 31 goes into 62. So I could factor out a 31, okay? And then I've got q to the 10th and then q to the 9th. Q to the 9th is 9 is my smallest exponent, so I'm going to factor out a q to the 9th. And then what you're left with, okay, 31 times what gives me 62? And that number, friends, is 2. And then q to the 9th times how many q's gives me q to the 10th, and that's just q, okay? And then when your greatest common factor is one of your terms, then you have to think about what could I multiply 31q to the 9th by to get 31q to the 9th? And the answer is simply just 1, okay? And that's it. So, factoring really shouldn't take, hopefully at this level, not too much work. But, the reality is we just want to remultiply this number back into each of these terms and end up where we started. Okay, so if you just do 31 times 2, it gives you 62. Q to the 9th times q to the 1st gives you q to the 10th. And then 31q to the 9th times itself gives you 31q to the 9th. Okay? All right, next one over here. Okay, so I can't factor out anything between 3 and 5. They're both prime numbers. 3 doesn't go into 5, so I can't do anything. I have an m to the fourth and an m to the first. I have an n to the eighth and just a single n. Because these are my smallest variables with exponents, these are the ones that I can factor out. So if I factor out an m times n, then we're left with 3m, okay, and so m times what? How many m to the first times what? How many m's gives me m to the fourth? And this is just going to give me m cubed. And then n to the what? Okay, n to the first times how many n's gives me n to the eighth? And that's just going to give me n to the seventh, and then minus 5, okay? And that's it, okay? That's what we've got. Okay, if you redistributed that m and n, you'd end up where you started. Okay, up here, all right, we've got 3 different terms. We've got 16c cubed d cubed minus 20c to the fourth plus 8d squared. Now, what I want you to see here is that in this term I have a c and a d. This term I have a c only, and in this term I have d only. So I can't factor out any variables because I can't factor out a d here, nor can I factor out a c here. So we have to leave it like that. Now, between 16, 20, and 8, the largest common factor, 8 goes into 16, but it does not go into 20. So it's going to be 4. So if we factor out a 4, then we're left with 4c cubed d cubed minus 5c to the fourth plus 2d squared, okay? And that's all I can factor out of that. So, okay, let's take a look at some application problems real quick. And it says that a square has a perimeter of 12x to the fourth plus 36x cubed inches. It says, what is the length of each side? Now, what we want to do, what we know is that the perimeter is just 4 times the side length, okay? And so what we'd want to do, now if we think of the perimeter of a square, if I think of the perimeter, that's just going to be 4 times the side length, okay? And so if we're trying to figure out the side length given an algebraic expression like this, then what I'd want to do is I'd want to see if I can factor out a 4, okay? And so if I factored out a 4 out of this polynomial, then we're just left with 3x to the fourth plus 9x cubed, okay? And so then our side length matches this part right here. So our side length is equal to 3x to the fourth plus 9x cubed. Now, the crazy part about this is that, we know that we can still factor out an x cubed out of each of these, but what we're trying to figure out is the side length of a square. And knowing that we have 4 sides of a square that are the same, I'm simply just adding this 4 times. Okay, hence multiplying by 4. All right, an equilateral triangle has a perimeter of 15x cubed plus 33x to the fifth feet. What is the length of each side? So an equilateral triangle is kind of similar, okay? The perimeter is equal to 3 times the side length, okay? And so, what I want to look at is, can I factor out a 3 out of this? And if we can, then let's do that. So, okay, I can factor out a 3 out of 15. That's going to give me 5x cubed. And then factor a 3 out of 33. That's 11x to the fifth. And that's it. So our side length s is equal to 5x cubed plus 11x to the fifth. Okay? And, I think the hard part about these two questions is that you're dealing with something where, you have a side length that is not an actual number, but rather an algebraic expression. So you kind of got to get past that. It's going to be okay. We will forge ahead. We will win the game. We will be victorious. We will get an A. All right, see you, bye.